Let's make sure we've got a calculator, we've got a pencil. Oh, Isaiah, your son's calculator and son's pencil. Go get you both of them. Go, 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 go. The pencils are over. Be careful, don't break my cup. Jamarian.
You could go, you could be late.
All right. So today we are talking about. Oh, did I just undo? Oh, did I stop my recording or is it still going? I somehow clicked off on something. I know you do. How about I promise you that these word problems aren't as bad as most, Caleb? These problems we have a strategy. So most of the time you see word problems, you got to figure out your own strategy, right? We're going to figure out a strategy. I think you're going to see that these aren't as bad as most word problems. Will you click on tools and see what pops up? It's there. Okay, cool. All right. So today we're talking about systems of equations, word problems. Systems of equations, word problems. And really what we're saying is we're learning how to apply systems of equations to real world problems. We're learning how to solve a real world problem using a system of equations. Make sure you don't have your earbuds in. If you get the hood on, Marquise, you without earbuds. Thank you. Oh, I see one. Go ahead and take your earpod out. All right. So what is a system of equations? What's a system of equations? Say it again, Claire. More than one equation. So we'd say two or more, right? More than one, so two or more equations, that's right. Let's start with that. So we're going to have a little bit more than that. So a system of equations is two or more equations. But there's something more specific. Put them right there. Put your chips up there.
My book bag.
Two or more equations. So what else? I mean, not any two equations can be a system. So what has to be true about those equations? So it looks like good on there right now, baby. Go ahead and put that up. Don't come in talking, baby. Don't come in talking. What has to be true about the two equations we have a system, in a system, Ari, do you know? All right, let me ask you this. Let me go back here and let you tell me which is a system and which is not. So nobody blurt out anything, don't talk. Just look at what I'm writing. I'll tell you, one pair is a system, one pair is not. Which one is the system? Is one the system or is two the system? Ari, do you know? Caleb, can I help her?
Just one.
It is one. Why? What's the difference between one and two?
One it has X and Y variables, and both of them, and there's the different variables, and then there's two, they don't, there's Z and X.
Right. So they both have X's, but then one has a Y and one has a Z. That's not a system, right? So Caleb worded it perfectly. They have the same variables, right? The two equations have the same variables. We have two or more equations. If you need something, get up and get it, Ira. You need a pencil. You may not. Two or more equations that have the same variables. So what we're going to do today is we're going to be writing the equations and then solving the word problem. Okay, writing the equations and then solving the word problem. Okay, I don't know if that is So the system of equations, that would be the solution, right, of the system of equations, yes. All right, so the solution to our system of equations, that's what tonight was just talking about, is going to be the value that makes both of these equations true. So back in this, this situation here, the value for x, when we solve, is going to be the same value in both equations, right? If 3 is the value that makes this first equation true for x, then it's going to be the same. So not only are the letters the same, but the values they represent are the same. And so that's important for what we're going to do today. All right, so we are going to write, first we're going to define our variables. We have to remember what it means to define a variable. And that just means to tell what it represents. So we have to remember what that means, and we're going to write, they seem like some basic steps, but I still think, even though they're not super descriptive, I think steps help. Okay, so the steps to solving a system. So, I'm sorry, to write a system. To write a system of equations, we're going to have to read our problem. And then pull out information. I did that in first grade, but I didn't tell them to write that in the notes. But I think that's important. That helps your brain kind of organize information. Kind of your brain starts working behind the scenes when you do that. You're using different parts of your brain. So we're going to read the problem. Then we're going to pull out information. Then we're going to define our variables. And there are going to be two. I'm going to use x and y most of the time, but you can use descriptive ones if you like. In other words, if we're talking about corn, you just see, if we're talking about ham, use an H or something like that. So we read the problem, pull out our information that we need. Sometimes we pull out information we don't need. That's okay. We're just reading through and working through the problem. Then we're going to tell what the variables represent. Then we're going to write our equations. So there's going to be two. And if you don't write two, it's not a system. Okay, honey, you're not writing anything. You don't pencil and paper out.
I had none of that.
I see that. Go get you some notebook paper from up there.
What about that?
No, go get it. No. All right. So let's go ahead and go to today's assignment. directions on a separate sheet of paper defining your variables. So we're actually going to define our variables on this one. On a separate sheet of paper, we're going to write a system of equations to solve each of the following. Let's not scratch that out. Let's write, we'll scratch it out. We're going to write right here, define variables in the blank. So we're going to define our variables, but we're going to write it right here. We're going to write the system of equations on our paper. Iris it up. We're going to show all of our work on our paper. We're going to figure out our answer on our paper, and then we're going to come back and write the answers in this blank. All right. So the first kind of system of equations problem we're going to talk about is one that's very popular on tests and high stakes tests. It's about the number of coins and the amount of money they equal and figuring out how many coins there are. So everybody read this on number one. Everybody read number one to yourself. Everybody read number one to yourself. You already read number one, Ryan? Read number one. Read number one, Jayla. Number one says, a purse contains $7.60 in quarters and dimes. In all, there are 40 coins. How many coins of each kind are there? So imagine a purse, your mom's purse, or your grandpa's purse, a teacher's, or what do you call that, a merce? If a man carries it, it's a merce, right? He wrinkled his nose at me. Anywho, a purse. Imagine a big purse and it's got a whole bunch of coins in it. They're dangling around, right? We know that there are 40 coins, but there's some quarters and some dimes. The question we're supposed to answer is how many of each are there? We know that there's $7.60. We know there's 40 coins, but can we figure out, without counting them, how many of each are in that purse? All right, so looking at the question is going to help us define our variables. It says, how many coins of each kind are there? How many coins of each kind are there? Well, what are the coins they're talking about? Riley, keep your head up, please. What are the kind of coins they're talking about? Isaiah, what are the kind of coins they're talking about? What are the coins? Number one. Sorry? Quarters and what else? Yes. So quarters and dimes could both be called coins, right? Then tell us there are 40 of those. We want to know how many of each there are. What right now we're doing is we're defining our variables. So let's use X for the number of quarters. And then Y for the number of dimes. So today's assignment, if you don't do all of these things now, you don't get credit. Remember, they don't have to be right, but you have to have done all the parts. So what we're trying to figure out is, and that's what it means when we assign something a variable, it means we don't know what that is, right? That's what we're trying to find out. So we want to find out how many quarters there are. We're going to use X to represent that number. How many dimes there are. We're going to use Y to represent that number. When we're done, we're going to come back and get the answer right here. So we read the problem, we defined our variables. We're going to go ahead and fill out some information. Tell me some information from that problem, Julia. Number one, tell me some information you think is important from that problem. Yeah, that's important. Tell me something that's important from that problem, Duha. Someone decides the 760. I can't hear you. We are using quarters and dimes. Okay, let's do that. Good. Quarters and dimes. And we're talking about using quarters and dimes, we have to have a numerical value for that, right? What is a numerical value of a quarter? How would you write that, Dior? How do you write a quarter? 0.25 or 0.25? Last period, somebody told me 0.25. You can write 0.25 or 0.25. Normally, I just do the 0.25. What's a dime, Ari? How would you write a dime as a decimal? Yep, 0.10. Okay. Something else important in number one. What else do you see? What's important in number one that we haven't written about, Marquis? Beautiful. There's 40 points. So now I have enough information to write two equations. Okay. So I'm going to go ahead and write that these are the x's and these are the y's for me because I know I forget things. All right. So if I know there are 40 coins, and I know x equals the number of coins, it represents the number of coins, and y represents the number of dimes, can anybody give me an equation that would represent the 40 coins based on our variables that we've defined? Is there an equation that we could write based on 40 coins and the x and y that we've defined? What do you think, Edie? Can you give me an equation to represent the 40 coins? Yep, x plus y equals 40. So x is the number of quarters, plus y is the number of dimes, and we know there has to be 40 altogether, right? So that's our first equation. So now, let's stop and think a little bit. We have $7.60 left. We haven't used the values for our quarters and dimes. We know in total it's $7.60. We're going to use the 7.6 for that. Oh, real quick. Somewhere in your notes, at the top, back over there, let's, no symbols in our equation, so there should be no dollar sign in there. So the dollar sign is a no-go in the equation. No symbols in our equation for right now. Caught up with me? Okay. So now we need another equation. We know in total there's $7.60, or altogether there's $7.60. That means they equal $7.60. So guess what? My second equation is going to equal. What's it going to equal? $7.60. I'm going to use the 7.6 there. So I know that the quarters and the dimes, and add them all together, they equal $7.60. But we've got to have a way to write that using our variables. So let's pause this for a minute and think about an example away from that. So let's say we have 3 quarters and 2 dimes. 3 quarters and 2 dimes. How much money is that? How much money is 3 quarters and 2 dimes? What's that? 95 cents, right? How did you find that, Marquise?
Yeah.
It is mental math, but when you mentally, what did you do? 3 quarters is 25, so 3. Right, how'd you get 75?
A quarter, 25 for each.
And you multiplied it by 3, right? So 3 quarters is the same as 3 times 0.25. Did you agree? And 2 dimes, we said, is the same as 2 times 0.10. And so that's 75 plus 20, that's 95 cents. You're exactly right. So that's the concept we need to apply to this problem. So that's the concept that we need to apply to write our second equation. So we're going to say some number of quarters times the value of a quarter. So 0.25 times x. Let me scroll down a little bit. Some number of quarters times the value of x, that's 0.25 times x, plus some number of dimes y times the value of a dime, so 0.10 y. If you multiply the number of quarters in the first, 5.25, and then add that to the number of the dimes in the first multiplied by 10.10, you're going to get $7.60. So now this is our system. So we've done the first three things on our steps to writing an equation. We're done with writing an equation. Now, our system. Now we have a system. We've been solving systems for about 2 weeks before this, or a week and a half. So now you can use substitution or elimination, but I'm never going to use substitution. I've taught you how to use substitution. If you want to do that, isolate one of these variables. With so many decimals and stuff, though, I much prefer elimination, so that's what I'm going to use. So looking at these two equations, is there something I can multiply? Now, I'm going to give you a hint. All this decimal stuff, we're not going to multiply this one by anything. Let's concentrate and multiply this first equation by something that will get rid of an x or a y in the system. Now, keep in mind, they're both positives, so the something we multiply by has to be what, right? Put your hand up. Has to be negative, right? I'm going to multiply this whole thing by something that's negative. What can I multiply it by? What can I multiply it by to get rid of one of the variables, x or y? Do you need to stand up? All right, sit up tall, maybe that'll help. Sit up tall. All the way, all the way, all the way. Close up. Oh, that's tall. Okay, good. What can I multiply the x, this whole equation by to get rid of the x or the y? What do you think, Jamarian? Remember, I'm going to add them vertically. I need opposites. I need a positive and a negative, the same thing. Julia? Yeah, I could do negative 0.25 for sure. If I do negative 0.25, I'm going to have negative 2.5 times x, add it to a positive 0.25x, and that's going to go away. I could have also multiplied it by negative 0.10 or negative 0.1. So that's what we're going to do. So let's go ahead and distribute this and write our new equation. So once you have the new equation written, now we're going to write the second original equation below it. And then we should be able to solve it from there. We're going to add them vertically. When we do our x's disappear. Solve for y. I can't remember. Is it 8 or 16? Somebody divide it. Jamarian? 2.4 divided by 1.5. Not negative 16, because they're both negative, right? So it's going to be a positive. A positive 16. Huh? 16? All right. So y is 16. What is y equals 16 represent in this problem? What does that mean? What does y represent in this problem? Look at y, where we defined our variable on your worksheet. So y equals something in words. What are those words? What are those words, viewer? Yes. So what we know now is there are 16 dimes. right? So if we know what y is, can we find what x now? Can we find the number of quarters now? And now, Gay, how do we find what x is now that we know what y is? What do you think, Jayla? Can you tell me how to find x? Say that again? Yes, very good. And do I want to plug it in this one with all these decimals? Oh, heck no. I'm going to plug it in this one right here, right? So x plus 16 equals 40. Let me grab your worksheet from up there. Get your pencils and paper, calculator. All right, so let's go back to our worksheet. And now we know x is, I can't remember from one page to the next, 24. So not just 24 though, it's going to be 24 quarters. You have to label your answer in a real world problem. And y is 16 dimes. All right? Does that make sense, Riley? Huh? It seems like a lot because we did it really slowly. We'll do the next one a little bit quicker and let you see. But anything with coins is going to be almost exactly the same thing. The first four are going to be coins. We're going to do 2 of those. Then we're going to try to work on number 5 and get that one in before. At least get it down to writing the system and you guys can solve it. All right, so let's look at number 2. Everybody read number 2 to yourself. Everybody read number 2 to yourself. When Jim cleaned out the reflecting pool of the library, he found 20 nickels and quarters. The mixture of nickels and quarters totaled $2.60. How many quarters did Jim find? You guys know what a reflecting pool is? It's kind of just like a little, like a fountain or someplace. Have you ever walked by those and people throw coins into them? So sometimes they call those, sometimes there's a fountain in the middle, which we call it a fountain. But sometimes there's not a fountain in it, it's just a pool of water. And typically, they take all those coins and they donate them someplace. Typically how that works. So in this particular problem, we know that there are 20 nickels and quarters. So that's like saying 20 coins, right? We don't know how much of each there are. The question asks us just to find the number of quarters, but we are going to have to divide 2 variables. We are going to have to write 2 equations. Even though we only have to give the answer for one, we have to use both of them to get the answer for one. Let's use a variable besides x and y. You can use x and y, but we could use a more descriptive variable. We're talking about the number of nickels and the number of quarters. So I'm going to use what can I use for one of my variables? What variable would be descriptive? Let's say for this says how many quarters. So what would be a descriptive variable used for quarters? What do you think, Duha? Q, yep. So we could use Q for the number of quarters. Ira, pick your head up, buddy. Ira, pick your head up, buddy. All right. And now, even though our question doesn't ask for it, we're going to use that question, but we have to know, all right, that's what we have to find. If we have to find the number of quarters, then we're also going to have to find the number of nickels. So N is going to represent the number of nickels. But at the end of our problem, we only have to tell what Q equals. All right, so we're going to try to solve this one a little bit today. Almost. Let's do this. I'm going to let you try to write it again. So I know there's 20 dimes and quarters. I know the total amount of dollars is $2.60. We have to know how much money a dime is. So how much does a dime equal? We just did that one. Oh, it's nickels, my bad. Yes. How do we write that as a decimal? Yes. So there's 20 nickels and quarters together. So a nickel is 0.05, and we know a quarter is 0.25. All right, so now that we remember that there's 20 total nickels and quarters, you want to try again for your equation? So tell me the whole equation. N plus what? Yes, perfect. N plus Q equals 20. We said N represents the number of nickels, Q represents the number of quarters. So the number of nickels plus the number of quarters is 20. We're not talking about money now, we're talking about how many coins there are. So this is the total amount. When you see the total amount, you're going to think the next equation is going to be equal to that total. Instead of 260, I'm going to write 2.6. So just like in the last equation, I'm going to take the amount the nickel is worth and multiply it times the number of nickels. Since I don't know what the number of nickels are, I'm using N. So it's going to be 0.05 times the number of nickels plus 0.25 times the number of quarters. So it's the exact same thing. Do you see the similarities, Caleb? There's kind of a little bit of a formula, isn't there? Very, very similar for these quarter system problems. So now, this is our system of equations. So what are we going to do next? This is not new stuff. Now, this is the stuff that we've been doing, that we tested on yesterday. So what are we going to do next? What do you think? Jayla, any idea what we do to solve this system now? Yep. Beautiful. Multiply the first equation by 0.05, she said. And that's exactly right. Be careful. I will tell you one of the common mistakes is, and I don't know why, with nickels more than others, a lot of kids are going to write 0.5. Remember, it's not 0.5, it's going to be 0.05. So now we're going to distribute that. Oh, did you say negative or positive? Beautiful. So that's rewriting that equation after we distribute that negative 5.05. Now I'm going to go back and write the original second equation without changing it. I made a mistake. I'm going to make sure you guys are not copying me. It's not minus and negative, it's just minus 0.05. And now I'm going to solve it. My ends go away, and now I'm left with just my quarters. If you had gotten rid of the quarter or the cubes multiplied by negative 0.25, you could have done that, but then you'd have to plug back in to find your number of quarters. Remember, the question only asks for a number of quarters, and when it does that, make sure you eliminate the one that you don't need. We eliminated nickels, so now we're going to be done after this. We're not going to have to plug back in this time because it didn't ask us to find the number of nickels. So here, I'm going to go ahead and solve for Q. And Q equals 8. So when we go back to our answer sheet, we're going to write Q equals 8 quarters. I do want you guys to turn in your answer sheet. Make sure you're scanning your worksheet rather. Parkeet? you do that to check to make sure that when you wrote your system, it was right. Remember guys, we gotta have a change of mindset here. I'm not teaching you to figure out how many quarters in there. I'm teaching you how to use a system of equations to apply to a real world problem. And I'm using this example. This is a super simplified example, right? A lot of you could figure that out. Trial and error might almost be as quick, or somebody who's counting them would be quick, right? If we had them, throw them all out there. But in real, you're right. In real life, you don't. But in real life, you might not ever use a system of equations, depending on your job. But I don't know what your job is going to be yet, and honestly, neither do you, right? And number two, that's a benchmark for this class. I have to teach you that because you're going to see it on the EOC. And it may not be an example that you can do in your head. So just like you can solve x plus 3 equals 10 without solving the equation without subtracting 3 from both sides, well, I taught you, what you were taught by someone else as well was subtract 3 from both sides to find the value of x, even though you already knew the value of x, right? So I'm not really teaching you how to find, that is not your life lesson here. The lesson is how to use the system of equations to solve this problem. So I feel you, Marquise, I do. But that's not the point of the lesson, right? The point of the lesson is not for me to throw you a purse with 20 coins in it and have you tell me how many there are, right? The point of the lesson is to give you a real world example where you can apply the systems of equations. So let's go to number 5 and see if we can quickly get at least the system written. Number 1, 2, 3, and 4 are all about points. So I want to do an example that's not about points, right? 1, 2, 3, and 4 are pretty cookie cutter. The other ones are not hard either, but they are a little bit different. I feel like the coin ones, your first equation jumps right out at you, right? These might not at first, but if we do at least one example together, you'll get it. Everybody read number 5 in your head. Everybody read number 5. Should see everybody looking at your paper. I guess you can read it from the board. Yeah, we're going to put in the worksheet. It's the direction stated, put that in the worksheet. Don't forget. Mrs. Jones is celebrating Gauss's birthday by having a pizza party for her 2 algebra classes. She orders 3 pizzas and 3 bottles of soda for a total of $23.34 for her second period class, and 4 pizzas and 6 bottles of soda for a total cost of $32.70 for her 7th period class. How much does each pizza and bottle of soda cost? So we're going to define variables here. This question tells me I need to find both now, not just one. The last question I just had to find the quarters. I've got to actually write both on my answer sheet this time. So I'm going to define both variables. I'm going to use P. How much does each pizza and bottle of soda cost? So P is the cost of a pizza. And we can do S equals the cost of a bottle of soda. And so the answer is going to be P and S. I'm going to try to stick on this page. So I've got to write 2 equations. So a clue for how to write these kind of equations is this total cost. That means one of my equations is going to equal $23.34. A total cost. The other equation is going to equal $32.74, right? I need to pull out some important information. There were 3 pizzas and 3 bottles of soda in first period, and they were $23.34. So guess what I'm going to use in my first equation? there were 3 pizzas. If I want to know how much the 3 pizzas and 3 bottles of soda cost, I'm going to take the number of pizzas and multiply it by the variable that represents the cost of the pizza. So 3 times the cost of the pizza plus 3 bottles of soda equals $23.34. So for the next one, I'm looking at the other. The other sentence says there were 4 pizzas and 6 bottles of soda, and they equaled $32.70. So that's going to be the information I need for my second equation. 4 pizzas, so 4 times the price of the pizza, 4 times the price of the pizza, plus 6 times the price of a bottle of soda equals $32.74. You remember when we reviewed translating? This problem is a lot of just writing all of that information for each equation within one sentence here. 3 pizzas and 3 bottles of soda for a total of $23.34. And that's my first equation. I've got to write it with my variables in it, but that's my first equation. So now we have, this is our system. We've already written our system. Now we should be able to solve that system. So I'm going to get you to the point where you can solve it, but I'm not going to solve it. So you guys will have to do the last half of number 5. So looking in here, if I just add them, I can't get rid of a variable. Can I multiply one of them by something? Do you have? By -2? Perfect. So if I multiply this by -2, now I'm going to have -6p minus 6x equals 2334. If you're not writing this down, we're literally doing your homework right now. You only had 8 problems on this assignment. We will have done 2.5 of them. Bye. Have a good weekend. Alright, so 4 times the price of a pizza plus 6 times the price of a bottle of soda equals $32.74. So now when we add those up, those go away. What did I do wrong? Pause. Everybody pause. What did I do wrong? I multiplied this, I multiplied this. Did I multiply this? No. Super common mistake. I hate to be the example for the mistakes all the time, but at least I'm good for something. And that's a negative. So -2p equals, I don't know, but you guys can do it from there. You guys have calculators. I can't hear you. I can't hear you. 8. 8? That's $8. 8? Say that again. 4668. No. Oh, 68. Thank you. This is not 64. This is 68, and I'm going to tell you. Right? All right. So go ahead and finish that one before you pack up. Add them together, or at least get the one, solve for the one variable before you pack up. All right, so remember, everything is going to be, you have to define the variable and give the answer on the worksheet, but everything else should be shown on your own paper. Make sure that you are numbering your problems and doing them in order I know number 5 is going to be out of order, but after that, everything else should be in order.